All right, so this is our third lesson, and we're just going to look at the horse race game again, which was part of the first lesson in this unit. So it says it's a review from chapter 1. It doesn't matter, it's unit 9. The horse race game, we predicted which horse we thought would win the race. The winning horse was determined by tossing the two dice and observing the sum of the two, which we did also last time. We just didn't call it the horse race game. Fill in the table below to find the possible sums of the two dice. So, for example, if I wanted to find the number that goes into this rectangle right here, I would take this 3 and add it to this row 3, and then the sum of these would be 6. But we should do that for all of them. I did it. I got all of them right account. Now, we have seen this before, though, so hopefully it doesn't seem like it's too new. But we're going to use this table to answer the following questions. Some of the questions may review from what we did in that last lesson, which we did the horse race game. So what is the number of the horse that is most likely to win? In this case, specifically, it looks like it would be horse number 7, because there's more 7s right here than any other number. Specifically, there are 6 of them out of the 36 total outcomes, right? Because there's 6 rows, 6 columns and 6 rows, giving us 36 total outcomes. The 7 is shown to repeat the most number of times. What horse is the second most likely to win?
8.
6 or 8, very good, yeah. So one of those two would be the second most likely with 5 out of 36. So how many times did that horse's number occur in the table? Well, we already did that. It was 6 times. What is the number of the horse or horses that are the least likely to win?
12 and 2.
Very good. Number 12 and number 2. And we can see that the 2 only happens once, and same with the 12. Only 1 out of the 36 for each. So how many times did that horse or horse's number occur? Once. How many total outcomes are there altogether on the table? 36. Recall, probability is written as a part-to-whole ratio. We're not so worried about that. Possible outcomes to the number of total outcomes. For example, the chances that horse number 3 will win is 2 possible ways to win out of 36 total possibilities, so 2 out of 36. So what is the probability that horse number 8 will win? Yeah, so there's 1, 2, 3, 4, 5 8s out of the 36 total possible outcomes. So 5 out of 36. The table shows the probabilities for each horse winning. This is called the theoretical probability of winning because we actually have not rolled the dice for these. Mathematical notation. A shorthand is P of 4, which is really shown right here. You don't really want to write all that stuff because it gets a little tedious. So we just write, this would be the probability of horse number 4 winning, would be 3 out of 36. So using the information in the table from the previous page, we should be able to fill in this table. All right. So the probability as a fraction, we'll do the fractions first, then we'll come back and fill in the percentages. But the probability of horse number 2 winning was 1 out of the 36, which is the same, theoretically, yes. And 12 was the same, 1 out of 36. 3, though, was 2 out of the 36. So 11 also would be 2 out of the 36, which we can see in the table above, right? And 4 would be 3 out of the 36. You can simplify that if you want, but I'm going to keep it as it is so we can see how many total outcomes there be. Then we got 4 out of 36 right here. And then 6, it appears that there are 5 out of the 36. Just put it on my desk. And 8 also, 5 out of the 36. And then finally 7 has 6 out of the 36. Now to change these into percentages, all we're going to do is divide these. So for example, 1 divided by 36 is 0.027 repeating, which as a percent, I would just multiply that by 100, and I'd get 2.7%, but I'm going to round that up to 3%. Now that means 1 out of 36 for number 12 also is 3%. And we'll continue this. I'll show this more specifically for 3. So for 3, for example, it's 2 out of 36. So I take 2 divided by 36. As a decimal, it's 0.05, and this repeats. But then I multiply that by 100 to get 5.5 repeating in percent. So I would round that up to 6%. Right here. We'll use the same method for the rest of them as well. Yeah, so right up in here, if I take this off, it shows we should round to the nearest whole percent. So that is what we have done. And we have all these percentages and these probabilities of fractions, which are very pretty. So now we're going to go in here, and we are going to add all of these. So the fractions, and this is another reason why I kept this as common denominators, because we can just add all these. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is 36. And there's common denominator of 36. This is just a total of 1. But let's go ahead and add all the percentages together as well. So when we do these as a percent, right here. Now as a percentage, this comes out to 101%. Can anyone tell us why this is more than 100%? Yeah?
Because we rounded up on a lot of them.
Correct! 4 of these we had to round up, whereas only 1, I believe, was rounded downwards. So that is why this is a little bit more than 100% right here. And that's okay. So, but when we do add all the percentages together, we should get 100%. Alright, but this one should be 100% right here. In fact, let me ask you guys these. 1, if we changed 1 into a percent, what would it be? It'd be 100%. It's the same thing, okay? Because we should get the same thing right here. So let's go ahead and look. If there are 200 races, 200 rolls of dice, how often would you predict number 7 would win? Well, let's look. Right now we're saying that horse number 7 would win 6 out of 36 races. And it should be equivalent now to 200 races right here. We just got to figure out how many races we would expect horse number 7 to win. So, using the fish method, 200 times 6 divided by 36. So 33.3 repeating races. So that's what we would expect horse number 7 to win if there were 200 races. It's very nice. Good job, horse number 7. Usually. Suppose the horses race 500 times. What is the prediction for how many times horse number 7 would win then? So this is going to set up the same way. We expect 6 out of 36 races to be won by horse 7. So now we're going to make that equal now to 500 races. We just got to figure out how many races that would be. So using fish method once again. And I've got 500 times 6 divided by 36. So 83.3 repeating races. Now we got to be careful on B because this is 1,000 times, but it's talking about a different horse now. Specifically, horse number 2. Horse number 2, we expected to win 1 out of 36 times. And we want to figure out how many races horse number 2 would win out of 1,000 races. So we just got to figure out X right account. Once again, fish method. 1,000 times 1 divided by 36. Alright, it is about 30, but we'll just go ahead and put this in. I got 27.7 repeating. Now, as it turns out, it also asks for horse number 12, which also has a probability of winning 1 out of 36 of the races. Right here. So it would set up the same way and you'd end up with the same number of races. In 1,000 races, you'd expect horses number 2 and 12 to win 27.7 races. Well, suppose we watched the horses race 500 times. Which of the following values would be the most likely result for horse number 5? All right, well, let's figure out what it would be exactly up at here. So horse number 5 right here. Horse number 5. We would expect horse number 5 to win 4 out of the 36 races. And this should be equal now to some number of races out of now 500 races. So we just got to figure out what that is. Now when we solve these, yeah, I got same as you, 55.5 repeating. So we would expect him probably on these 4 choices, 50 would be the most likely choice. And the explanation is really just in the work up in here that we've shown. Alright, so just real quick with old fish method, and particularly this is maybe like a percent proportion one. Doesn't really matter what we're looking at. So maybe we say 3/5 is equals to I don't know, 18 over something like this. Okay. Now the other ones didn't set up quite like this, but fish method we know is going to have all 4 spaces for all 4 values, and it's always multiply, divide, and equals. This one is not really a percent proportion, it's just a regular proportion, like the other ones we did. It could be though. So the fish is always, we got to make the tail starting with the x first, so we make the tail, which is just a straight line, and that takes us to our first value. Then we cross down here to this next one, 5 in this case. We'll bring it up to the 3, and then when we end off at x, it gives us a nice little fish rod account, which is quite adorable. You could plug this into your calculator now, and then you'd solve it.